Okay, so the very last proximity measures that we're going to discuss is the cosine similarity. So I want to draw your attention to this cosine similarity measures the similarity, not the distance between two observations. And the cosine similarity is widely used to measure the similarity among documents, so text data. What earlier we have mentioned that we can represent documents as vectors of words. So in this example, we have document 1 holding team 5 times, on hockey 3 times, soccer 2 times, and the word win twice as well. And document 2 has a different distribution of those terms. So in our data structure to represent document, we have documents in the rows. We have all the terms that occurred in this corpus of documents on the columns. And those terms are called the vocabulary of this corpus. This data structure, what we observe is once a document is represented as a vector, so if we imagine that in a multi-dimensional space, every term here holds one dimension. So one term represents one dimension, and we will be able to project or draw this vector in a multi-dimensional space like this. So depending on the coordinates, so all the values in this vector for document 1, along different dimensions, we will be able to draw document 1 vector as this, and 2 and 3 and all the others. Once we drew that, we can make an observation that the angles formed by two document vectors are going to be different. And the angles is actually determined by the similarity of term distribution of document 1 and other documents, right? If document 1 and document 2 have exact term distribution, so every term that occurred in document 1 also occurred in document 2. If they also occurred at the exactly same frequency, we will see that document 1 and document 2 are going to overlap. And they will form an angle of 0. And that angle of 0 is going to have a cosine value of 1, which means that two documents are exactly the same. The far apart of term distribution between two documents will form the angles between two vectors that are greater. So based on this intuition, what we could do is to compute the cosine value of the angle that's formed by two documents. So this is cosine similarity. Cosine similarity takes the value between 0 and 1. When cosine similarity is 1, that means the angle is 0. Therefore, the two documents are exactly the same, have the highest similarity. To compute cosine similarity, we will use the dot product of the two vectors divided by the product of the length of two vectors. So to see an example, so we have two documents, document 1 and document 2. The term distribution looks like this, and we will first compute the dot product. So this again, either review or new things that you learn. A dot product is just a sum of pairwise product of every element in two vectors. Okay, so here we have 5 times 3 plus 0 times 0 times plus 3 times 2 plus 0 times 0 plus 2 times 1. So that gave you the dot product. D1, D2 are vectors, but their dot product is one value. It's a scalar value. Length of D1 is computed using the Euclidean distance formula, which is one special case of the Minkowski distance that we learned earlier. So here the length of a vector this is the origin of the coordination system. So here is 0, 0, 0, 0, 0, 0, 0. How many, whatever dimensions that you have, that's that many zeros here. And this document has the vector is this, right? So apply the distance measures that we learned earlier. We will do 5, it's basically 5 squared plus 0 squared plus 3 squared. All those sum take the square root, because we're computing the distance against the origin. So 5 minus 0 is 5. Therefore, we have 5 times 5 here. Similarly, we will compute the distance of 2 D2, and that having all those distance and dot product, we got the cosine similarity value of 0.94. This tells us that these two documents are very, very similar. So again, I want to emphasize cosine similarity measure the similarity, not the distance. Okay. So we mentioned that document cosine similarity is most often used to measure document similarity. It can also be used in other situations where the similarity of these two things are determined by the distribution of their values in each of the dimensions. So some other examples that we're going to see later in the semester is to use the cosine angle to determine the similarity of two things in high dimensional space. That can be used in clustering analysis. Some other applications including gene sequence analysis. So cosine similarity is used quite widely and a very interesting measurement. This is going to conclude my last video for this chapter 2. The topic on data visualization will be covered later because chapter 2 has lots of content.